Okay, well, it might be fun to model each of these little dots onto all 6 sides of the dice in Fusion and really work to perfect that model in 3D. It would also take effort, and it would take time. I actually care more about making this die out of metal, and so I want to talk about how we don't have to model anything, that these circles are enough to build the cam for our metal cutting operations. So let's do it. Switch to the manufacture mode and make a new setup. And for the work coordinate system origin, let's use a model box point because we've already cut all the stock away. We've revealed the model. The point we're going to use is this one here on the top, in the center on X and the center on Y. And for the stock parameters, we're going to use a relative size box, but we're going to zero out all the offsets because there is no more stock. We've already cut it away. Go ahead and name your setup .1 and consider for a moment that we're going to make 6 different setups, so it's pretty darn important to name these .1, .2, .3, .4, .5, .6. Let's start with .1. And let's say hello to the new tools we're going to be using. This is a center drill, and this is a drill. Drills are really great at drilling holes, but they struggle a bit at the very start. They tend to skitter around on the surface because of the web. The web is this ridge of metal from the point out to the start of the flute. The web doesn't do any cutting, which is a problem when the point first encounters the material, because it has to smush its way down into the material to get deep enough for the flutes to start doing some cutting. And in that moment of smushing into the material, it tends to skitter around and end up in a spot anywhere but at the center of where the hole was supposed to be. To solve that problem, we use the center drill. It's also got a web, which is also going to have this skittering problem, which is why the center drill has this massive shank, giving it the rigidity it needs to resist that temptation to skitter off center. And the only part of the center drill that we're going to use is this tiny little taper out here on the pilot. We're just trying to make a little conical pocket for the web of the drill to land in. Back in Fusion, click on this button to add a drilling toolpath and select our center drill, tool 13. Change to the geometry tab and change your selection mode to selected points, and then click on this circle. Good, our center drill is coming down in the right spot, but it is coming down way too far. We only want to use this taper at the very end of the pilot. So go to your heights tab and set your bottom offset to be just 30 thou down, -0.03. That's just enough to create that conical pocket for the drill. Any deeper and we'll risk chipping the drill over time. Good, click OK. Let's add that drilling toolpath. So click the drilling toolpath button again, and this time choose tool 14, our 1/8 drill, 0.125. Then the geometry tab, selection mode, selected points, and click on that same circle again. And again, we're way too deep. We're almost going to drill a through hole, whereas we want to make a tiny little blind hole that just goes down a bit into our metal. Let's try 70 thou, -0.07. And just because we're starting to get pretty good at this, let's add a chamfer to the top of that hole. 2D chamfer, select the chamfer tool, tool 12, and then select that same circle one more time. And after you do, click on the Passes tab and look back at these chamfer parameters that we had been setting to 0. Notice we were setting them to 0 before when we were selecting the bottom of a modeled chamfer, something that we had modeled in 3D. But we don't have a modeled chamfer here, we just have a circle at the top. This is precisely the scenario where those chamfer parameters suddenly become useful. It's also a scenario where it's difficult to see what our tools are doing. So let's make that easier to see. Open up your models folder and dig in until you find the bodies folder, and turn off the visibility on the body of your cube model. By making our model invisible, the only thing we're looking at here, the green, is the simulation of our stock. Now we can see, if we click through our toolpaths, how the center drill makes the conical divot, how the drill is able to drill deeper, and how the chamfer does nothing at all. What's going on here? If we zoom in close, we can see the little blue line of the toolpath. The chamfer tool is coming down and swooping around in a circle there. Why isn't it cutting metal? Let's simulate this toolpath to get a better view. As I bring the chamfer tool down, I see it swoop around, and look at that. It is maybe cutting the tiniest little bit of metal. What's going on with that green little ribbon around the top edge. Well, on the one hand, this might be a computer problem. Simulations are expensive, and so they can only ever afford computationally to be approximations of what the metal's actually doing. So maybe these are just graphic artifacts, the limits of my graphics card revealed. But if I look at the simulation again in action, I can see that the angle of the chamfer tool really does come right up to that circle that defines my hole. So let's exit the simulation, edit that 2D chamfer toolpath, go back to the passes tab, and see if those chamfer parameters can get us the rest of the way. Look at this chamfer width. It's currently set to 0. Let's set it to 10 thou. That's the same size as the chamfer we modeled in 3D, out on the edges of our cube. We don't have one modeled here, but let's see if we can cut a 10 thou chamfer anyways, just using these cam parameters. Click OK and see how immediately the simulation looks promising. Go ahead and re-simulate and drag through time to see, yes, we can cut a 10 thou chamfer even if one hasn't been modeled. Next up, we're going to show how if you have center drilled, and chamfered one dot, then you can do the rest. It's a piece of cake.